Okay, let's talk about how to solve for a limit when you've got a radical. So, okay, first things first, our like red flag here is when you have a radical. All right, oops, radical. So radicals lead to something we call rationalizing, which is when you essentially remove the radical, right? And in this case, it's going to allow us to simplify. And often we have to use the conjugate if you've got a binomial, all right? So you're going to use conjugate if have a binomial. All right, so here's what I mean by that. Let's say we've got, I don't know, something like this. Let's say we've got the limit of x minus 9 over root x minus 3 as x approaches 9. Okay, so step one is to always substitute and see what happens. So if we do that, we're going to have 9 minus 9 over root 9 minus 3, and 9 minus 9, of course, is 0, and the square root of 9 is 3 minus 3 is 0, which means this is indeterminate. So we have to do more work. Now, your choices on doing more work are the following. You can factor, you can rationalize, or you can find a common denominator. So, because we have this radical, this is going to lead us to rationalizing, and it's all because we have a radical. Well, and we can't factor here. So we're going to rationalize this in hopes we can cancel something out. So here's what that looks like. We're going to say x minus 9 over root x minus 3, and we're going to multiply by the conjugate. So the conjugate is root x plus 3. And we're going to, rationalizing means you do the same to the top. You multiply by the same thing on the top and the bottom, because anything over itself equals 1. The conjugate means we have switched operators. So our operator here is subtraction, and here it's addition. So we've switched our operation. All right, now we are going to multiply. So on the top, I'm going to be smart about this. I'm going to just let this sit here for a second, and I'm going to leave x minus 9 times root x plus 3. And the reason I'm going to do that is because I know my ultimate goal is to cancel something out, and I cannot cancel anything out, or my chance of canceling it out is better if I've got binomials. They just tend to cancel out better. So on the bottom, I'm going to go ahead and I'm going to multiply down here because I know that I've multiplied by the conjugate for a reason. It's going to create difference of squares and give me a better deal. So root x times root x is x. And then, of course, I would multiply root x times 3 and get 3 root x. And then I would do that again and get negative 3 root x, which I know is going to cancel out, so I'm not going to bother to even write it. Then I'm going to do negative 3 times 3, and I'm going to get minus 9. Now, look what's happened. I have an x minus 9 in the bottom and in the top. These are going to cancel. And I'm like, score, because that's what I was after this whole time. I needed to cancel something out. And what's left is root x plus 3. Now that something's been canceled, I am going to substitute in my 9 again. And I'm going to say root 9 plus 3. And hopefully this time I won't get indeterminate and I'll get a value. And the square root of 9 is 3 plus 3 is 6. And that, my friends, is the limit. And that is how you find the limit by rationalizing. Now, in this case, what we were rationalizing was in the denominator, but that's not always the case. Sometimes it's in the numerator. Like let's do one that's, I don't know, a little harder. Let's really live on the edge here for a second. Let's say we've got the limit of root x plus 2 minus root 2 over x. Okay, so this is a hot mess. As x approaches 0. All right, so the first thing we always do is just try our substitution. Maybe we're going to get lucky and this is going to work. And nope, root 2 minus root 2 is 0 over 0. This is indeterminate. Need to do more work. Again, your choices are factoring, rationalizing, or finding a common denominator, and rationalizing is the clear winner here. So I'm going to take the square root of x plus 2 minus root 2 over x, and I'm going to multiply by the conjugate. This time my conjugate's in the numerator, and that's okay. I'm going to change my operator to addition. So I'm going to have root x plus 2 plus root 2 over root x plus 2 plus 2. Again, this equals 1. Anything over itself is 1, and if you multiply something by 1, you've done nothing. Okay, now let's multiply this, and let's be smart about this. So if we have root x plus 2 times root x plus 2, that gives us x plus 2. If we multiply the outside and the inside, we know that'll cancel. And so let's do our last ones. Negative root 2 times root 2 is going to be negative 2 over. Now, we learned last time we're better off just leaving this alone and not multiplying that part through, because sometimes it works to our advantage. So here's what's left. Look at this, x plus 2 minus 2. Well, plus 2 and minus 2 are 0, right? Can we agree that that's 0? And now we have an x, do you see this? We have x over x right here. And what can we do with that? We can cancel that out. And what's left? Remember, you have a 1 on top still. Don't miss that. And you've got root x plus 2 plus root 2. Now that we've canceled something out, of course, that means it's our time to shine, and we are going to pop that 2 or that 0 back in, and we're going to get 1 over, 0 plus 2 is 2 plus root 2, which, if you're keeping track, remember those radical rules, is 2 root 2s. Take it to a decimal if you'd like, leave it as a radical, although you're really not supposed to have radicals in the bottom because, hello, etiquette, which is why we rationalize to begin with. Okay, that's all there is to it. So, quick rundown. You always substitute, see if it works. You get 0 over 0, do more work. Rationalize, use the conjugate. That means you switch the operator. Don't multiply the part that's not being rationalized because it usually works to your advantage. Cancel something out. Substitute again. Try for a value, and we're out.